Saraswati 2.0 Podcast Talks.
Hello, everyone. Thank you for being with us. And today we are back with the podcast 2, where we will be talking about innovative technologies and pilot projects. Here are some of the innovative technologies with an overview.
Technology that we implemented is utilization of electrically conductive biofilter. The wetlands they are using mostly utilize non-conductive material as a support media. So having utilized electrically conductive material, where we typically utilize the carbon-based material supplied by our Spanish partner, Senta. So the advantage that we gain is otherwise in the wetland system, if we don't harvest the biomass properly, then eventually the blocking of the media will happen. But over the period of more than 2 years of operation of this electrically conductive wetland system, we were never required to clean the wetland bed, and excessive biomass generation is not being observed. At the same time, because of the better electron transfer capability due to electrically conductive media, it also helps in improvising the nutrient removal efficiency apart from the organic matter removal efficiency.
One of the treatment systems we've been studying is anaerobic digestion. Now, if anaerobic digestion is not properly operated, organic pollutants will still remain in the wastewater. Now, those would enter then, for example, local rivers or lakes. And once they enter, what will start happening is they will start degrading further. But in that process, they will, let's say that process will consume all the oxygen in the, let's say, that is dissolved in that lake or in that river, and therefore make the environment no longer suitable for fish or other type of animals to thrive. Now, by, let's say, introducing the technology as we were working on, we will have better control over the quality of the effluent, and normally this depletion of oxygen should not be happening anymore, or at least you will have much better control over that.
It's a batch activated sludge process. It's very common. It's already working in almost all over the world. In the small plants, some plants, they're working at the larger or maybe higher capacity. And here the activated sludge, we modify the activated sludge, we operate in the batch mode so that we can, along with the nitrogen, along with the organic matter and suspended solids removal, we can remove the nitrogen and phosphorus. That is the main thing. And by controlling the cycle, we can take the peak also, we can manage the peak, if we got the less flow, we can change the cycle, and as per the flow, by dissolved oxygen control, we can control the blower, or we can save the power based on the flow.
We then worked out what we thought would be a worthwhile proposal that would allow taking work that we had done here using a particular process that we had scaled up here to treat nitrate-bearing groundwater, to extend it to the applications that Professor Phillips' group was looking at related to wastewater.
So with our Ben Gurion University partner from Israel, so we have come up with the ion exchange membrane filter for removal of nitrate from the secondary treated effluent. That technology also they have tailor-made with the 2 meter cube per day treatment plant module, and that can be implemented as per the need. The more and more modules can be augmented to meet the need. So that is also another innovation that the Saraswati 2.0 is offering for producing the effluent free from nitrogen to be used for any downstream non-agriculture purpose. If you have to use aesthetic enhancement or many other purposes, so the secondary treated effluent can be polished.
So, after knowing the innovative technologies and pilot projects, here are some of the feedbacks as well as the lessons learned during this journey of Saraswati 2.0.
It was an opportunity to work in an actual industrial environment, whereas we had been working mainly just here at our institute, using existing water and spiking it with nitrate. While as here, we would get a chance to work on a real process stream.
All over the world, it's working well. And here we tried the same thing that, okay, whether we can get high quality effluent by this kind of technology for in a small scale. We try to get more inputs that, okay, these are the problems we generally face. So for generally putting this plant, we have to have this kind of extra precaution we have to take compared to the larger.
Thermal hydrolysis, though it is widely implemented by our partner, but under Indian condition, we got opportunity under this project to test it and hands-on analyzing the benefit of it. So upfront, it demands energy for thermal hydrolysis of the sludge, but then better dewatering characteristics of the sludge, enhancing methane production by about 50%, and the deactivation of all pathogens present in the sludge, making the sludge suitable, classifying it as a class A sludge for soil application. So these are the definite advantage that this process offers downstream. So these are all innovative aspects of implementation of Saraswati 2.0 project.
Talking about Saraswati 2.0, of course, it has been very smooth journey, but journey can never be smooth only. We all face challenges. So let us know the details of the challenges what the project Saraswati 2.0 has faced and how we envisage that we'll be able to overcome that in our next phase, as well as how to assess the long-term sustainability as well as the impact of these technologies. That has also to be discussed.
The problem is, and this is something that one of the realizations that we came to, is that the contactors are too expensive for an application that is essentially removing a waste and not recovering a valuable byproduct. Originally, these contactors were made to recover acids. The acid has value. So if you can recover the acid, you can justify the cost of the contactor. But in this case, it could not be justified. And therefore, we ourselves are looking into reimagining how the contactor would be assembled so that we could come up with a contactor that is significantly less expensive, but could treat large volumes in a single pass, as we were able to do with the spiral on contactor.
The only thing is that problem is that broken equipments, like equipment. That's why I told you, okay, let's say it comes in my mind, 3 or 4 plants of same capacity, we can have a store standby. We can repair it. We should repair and fix it. Otherwise, we cannot really take the fruit of this kind of system. And it's very, very good. No issue. And design already there. We have designed it accordingly. There's no problem with the design. Auto control, everything works well. Only things that we have to repair the pump, we have to repair the blower, we have to repair the decanter frequently, we have to repair the valve. But repair takes time, therefore it's better to change it and then send it for repair to the factory.
The project started before COVID and ended after the COVID pandemic. Now, and basically the whole pandemic and let's say the response of let's say other governments on the planet was somewhat different, and also affected the possibility to operate a pilot plant in this case. But I think it even made more urgent the fact to kind of have a override modus where less human intervention is needed, because people were kind of stuck in their houses, and therefore the wastewater treatment plant also was, let's say, at risk of not operating properly. I think, wastewater treatment is has an extreme impact on health, and I think that's something which is often forgotten. But a lot of the health improvement that we've seen, particularly in the Western world, resulted from, let's say, disinfection of potable water sources, and also sanitation systems, which were basically designed by civil and environmental engineers. So that already boosted an enormous amount of, let's say, the health, the general well-being of the population. Now, what happened since then is that that system worked pretty well. So the planet became much more populated. So now you get much more people that need this type of system. So it's in a way, it's a question of process intensification, where we would be able to provide the same kind of solutions to, let's say, instead of 1 to 2 billion, but to 6 and now even 8 billion people, which of course makes it much more challenging. At the same time, I think if we would manage to eradicate a lot of these waterborne diseases, either through drinking water that gets infected with, let's say, municipal wastewater by not treating the wastewater, or people using wastewater directly or being in contact with that wastewater, that would have, let's say, massive implications, because I think up to today, there's still millions of people each year that get affected with these type of diseases that could easily be prevented if there would be enough, let's say, political commitment to really eradicate these diseases based on technology that's known, but needs to be intensified because of having a larger population.
We also hope that in doing our future design, that we'll be able to provide a design that is inherently robust and resistant to biofouling. So these are the two challenges that we recognized at the end of the project that told us that if we really want to go forward, we have to address both of those issues. And that is essentially what we're doing now within other research frameworks. But to be able to get to this point, we couldn't have gotten here if we hadn't done this project with the Saraswati project. This allowed us to have this realization. It also gave us the confidence, based on the success that the IET group had, that yes, if you've got the right technology and you've got the right kind of contactor, it can work in an actual industrial setting, an actual practical setting. So this is these are the realizations, the lessons that we learned, that now we're taking forward as we go forward.
So thank you all experts as well as audience. Experts mainly for sharing their views as well as the knowledge about the innovative technologies and pilot projects in the Saraswati 2.0 and explaining the challenges that you faced. Thank you, audience, for your active listening as well as your interest. And stay tuned with us for our next podcast, which will be more focused on challenges and solutions in implementing Saraswati 2.0. Thank you all.